Hello viewers, I'm Kausalya. Today we are going to solve problem 3 which is related with topology of networks. The problem is for the network shown, draw the graph, a tree, ties its schedule and the current through 20 ohm. Also find the voltages across various resistors. So here a network is given and we have to draw all these things. First graph, then tree, then ties its schedule and the current through 20 ohm resistor. Okay, we have to find, and also we have to find the voltages across various resistors. So in this circuit diagram, how many nodes we have? Totally we have 4 nodes, namely 1, 2, 3 and 4. And how many branches do we have? Branch is nothing but the line segment, right? The line segment between any two nodes is known as branch. So here you see between A and B we have 20 volt. So this is your branch 1. Between D and A we have 40 volt. So this is branch 2. And this is branch 3 and this is branch 4 and this is branch 5. So total number of branches are 5. So here number of nodes is 4, namely A, B, C and D. And number of nodes are 4, A, B, C, D, and number of branches are 5. And number of tree branches, this is given by the formula total number of nodes minus 1. So 4 minus 1 which is equal to 3. And number of loop links is given by B minus N. So it is 5 minus 3 which is equal to 2. And number of independent links are that is 2 in number. So here the first step is drawing a graph. So how to draw a graph? You have to replace all the elements by simple line segments. So first write down the nodes and you have to connect the nodes, right, by simple line segments. That's it. And here you have to mention the direction for the branches. Apart from that, here we have 2 loops. So the loop currents are also mentioned here. So this is the way to draw the graph. And again here the direction of the branches we can decide by ourselves. There is no specific rule. Now the next thing is we are going to draw the tree. So here how to draw the tree? So that is initially we had by using the formula. You see here number of tree branches is 3. So we should draw the tree in such a way that it has only 3 branches. So here the tree is drawn like this, okay, totally 3 branches. So here we are considering this, okay, A, B, A, C and A, D. Again you have to keep another thing in your mind that the tree which we are drawing should never form a closed path. Okay, that is much more important. That is a key thing you have to remember while drawing a tree. So here A, B, A, C and A, D are the branches. So you see again when you look at this graph, okay, these 3 are the branches and this part, okay, this 2 and 3 they form the links, right? So totally we have how many branches? Totally we have 5 branches, right? You see 1, 2, 3, 4 and 5. So how many branch currents will be? Again 5 branch currents will be there. So they are mentioned as capital I1, I2 up to I5. And here this I1 and I2 are the link currents or loop currents. Now we are going to frame the tie-set schedule. So how many loops do we have? We have 2 loops and totally we have 5 branches. So just make a tabulation like this. Now we are going to write down the values. So first consider your loop 1. So loop 1, you see how many branches do we have? What are all the branches do we have? This is our loop 1 because the respective current is I1. So here we have A, B, B, C and AC. Right. So right, let us go by branch numbers, okay, that will be fine, right? Okay. So 1, 2 and 5 are the branches which form the loop 1. So in 1, 2 and 5 you have to write the numbers. So 3 and 4, these 2 branches does not become a part of this one. Therefore here we are simply writing 0. And the next one is we have to look at the direction of the loop current as well as the branch current. So here you see, just look at this branch 5, okay, the direction of this I1 and this branch 5 is same. Again, when you look at this part, okay, branch 1, again the direction of this loop current and this branch current are same. And here again, the direction of the loop current and the branch current are same. So, for this branch 1, branch 2 and branch 5, here we have to write plus 1. Now, we are proceeding with our loop 2. So, in loop 2, 3, 4 and 5 are involved. So, under branches 1 and 2, we have to write 0. So now you see branch 3 and this loop 2 current are in the same direction. So here we have to write plus 1. And again here also they are in the same direction. You see this branch current is like this and again this loop current is like this. So here we have to write this as plus 1. And again here in this branch 5 the current direction is opposite. So there we have to write minus 1. So here you see it is 0, 0, plus 1 and minus 1. So now we are going to write the voltage equations. So voltage equations are written by considering the rows. So when you look at the first row, you see 1 into V1 plus 1 into V2 plus 1 into V5 is equal to 0. So again when you look at this row 2, 1 into V3 plus 1 into V4 minus V5 is equal to 0. So this is your equation 1 and this is your equation number 2. So next we are going to write the current equations. For writing current equations, we should look column wise. Right. So here you see in this column we have plus 1. So this shows that this capital I1 is equal to small I1. Likewise, we have to look each and every column and we have to write the corresponding currents. For example, when you look at the second column, you see the capital I2, okay, the respective current is I2. So, current flowing through the branch number 2 is I2. So, I2 is equal to, here it is because the current flowing through the loop 1 is small I1. So, here it is, that is I2 is equal to I1. From this, we can write it as I3 is equal to, here the plus 1 corresponds to loop 2. So, here I3 is equal to I2. And here similarly, I4 is equal to again I2. And for this column, we have both plus 1 and minus 1. So, here we have to write it as I1 minus I2. Because this plus 1 corresponds to the current in loop 1. So, this is plus I1 and here it is minus I2. So, here we have to write it as I1 minus I2. So, here finally we had written the current equations. Now, we are going to look back at the original network. Okay, that is the network which is given as a problem. So, here when you look at the original network, so when you look at this network, from this network, we are going to write the respective voltages. So initially the source voltage, okay, this V1 is taken as minus 20 and the next one is V2. V2 is taken as 10 into I1 and similarly, you see here totally we have 5 branches, therefore we will be having 5 voltages. So here we are always considering the source voltage as a negative terms. So here you see V1 is minus 20 volt and V2 is, this is your branch 2. So the respective current flowing through this branch 2 is I2. So here we have to write it as 10 into I2. And here this is V3. V3 is written as 10 into I3 and V4 is minus 40 volt and V5 is 20 into I5. Right. These are all the respective voltage drops from the given circuit. So here we have written the respective voltage drops. Now we are going to substitute the values of I2, I3 and I5 in terms of loop current. So here V2 is 10 I2. So what is I2 here? I2 is nothing but I1. So just replace it with I1. Next one is 10 I3. So what is I3? I3 is again equal to, here it is I2. So 10 into I2. What is I5? I5 is I1 minus I2. So here this I5 is replaced by I1 minus I2. Now we are going to substitute these values in equation 1 and 2. So this is your equation 1, V1, V2 and V5. So we know all these values. So just substitute. So V1 is minus 20, V2 is 10 I1 and V5 is 20 into I1 minus I2. So when you simplify, so here it is minus 20 plus 10 I1 plus 20 I1 minus 20 I2 is equal to 0. So once you simplify, here we have, you see 20 I1 plus 10 I1 becomes 30 I1 minus 20 I2. I am moving this number minus 20 to the right hand side, so it becomes plus 20. So I am dividing this entire equation by 10. So we have 3I1 minus 2I2 equal to 2. Okay, mark this as equation number 3. Now consider your equation number 2. It is nothing but V3 plus V4 minus V5. So here again just substitute the values. Once after substituting, just simplify. Okay, minus 20 into I1 minus 20 I1 minus 20 into minus I2 becomes plus 20 I2. Again we are combining I1 I2 terms together and I am moving a number to the right hand side. So when you divide this entire equation by 10, again it comes in a simplified form. You see minus 2I1 plus 3I2 equal to 4. Again I am dividing this by 2, or it is not needed. Okay, you can take this equation directly and you can solve. Again it's up to you. So here it becomes minus I1 plus 1.5 I2 equal to 2. Okay, once this is done, then solving these two equations will be easy. Anyway, this is also easy. Okay, this is also not tough. But when you further reduce the equation in simplified form, it will be very easy for you to simplify. Now, we are going to solve equation 3 and 4. So, when you simplify, you see here, we are multiplying this equation 4 by 3. So, I am getting this value. So, I1 get cancel and here I have 2.5 I2 is equal to 8. Therefore, I2 value is 3.2 amps. So, once you substitute this value in any of this equation, okay, either in 3 or in 4, here we get the value of I1 as 2.8 amps. So, the value of loop currents I1 and I2 are calculated. So, the next thing is we are going to calculate the current I5. I5 is I1 minus I2. So, 2.8 minus 3.2 gives you minus 0.4 amps. So, what does this minus sign indicates? This minus sign indicates that the assumed direction is wrong. We have to consider the current flow in the opposite direction. Right, that's it. And now, what is the value of V2, V5 and V3? V2 is given by 10 into 2.8. So, here it is 28 volt. And V5 is 20 into I5. So, the value of I5 is minus 0.4. So, here it is minus 8 volts. And V3 is 10 I2. So, 10 into 3.2 which is equal to 32 volts. So, that's all. This problem gets over here. If you have any doubt, let me know in the comment section. Thank you.